here's pre-calc. This is problem 8-121, and this problem gives you a little diagram, and it's asking about these two forces, if they're going to be able to lift this 100-pound box. So we don't have a lot of physics, like we haven't been talking a lot about physics, so we know hopefully how to add the vectors. So it should occur to you that the vertical components, when I add them together, I don't even know if this makes sense, but like these vectors both have an upward component to them. Like they're both, you could imagine they're both kind of, even though they're at angles, they're not lifting straight up, they are lifting a little bit. This one probably more, wait no, actually this one has a steeper, oh wait no, this one has a steeper. Well, we don't have to guess about stuff like this. We can actually work this out. We can get the component form of these. So we can, we know how to, I don't know, hopefully we know how to get the vertical and horizontal components. So basically, this is a hypotenuse, so I drew them into two right triangles, and I'm just, to get them into component form, I just want to find the side lengths. So that's easy. This one's a 30, 60, 90 triangle, so the short side is going to be half of the hypotenuse, so I just used my special right triangle, and then the other side is 15 root 3, the side across from the 60. So I just wrote this in component form. So this is component form. And then I did the same, I wanted to do the same for this, but it wasn't a special right triangle. So the way you can get your side lengths is you're going to use SOHCAHTOA, like, well, you don't need the TOA part. I'll write it out, but you need cosine for down here because this is adjacent over hypotenuse, so I used cosine. And so I said cosine of 50. I didn't write it all out, but I said cosine of 50 equals adjacent, which is the thing I want, over hypotenuse, but the hypotenuse is 75. So if I multiply both sides by 75, I got 75 cosine 50. And then likewise, you do the same exact thing with sine to get this vertical component, and then you'll have 70 sine of 50 will give you this side length. Okay, so now I can put these in my component form, and then I'm just going to add them component-wise. Like, it doesn't even matter, this horizontal part doesn't even really matter because we're only trying to see if we can lift the box. So, but I added them up, and I got, a resultant vector. These vertical components are what matters. These, when I add them together, they're not enough to overcome the downward component of our box. So the way your book writes it is like we're going to subtract the components of the box. Well, that would just be 0 horizontal and negative 100 vertical, and it gives you a negative, is it 27.5? But that's not even, like, I didn't even bother doing that part. I just looked at this number and I said, this number isn't strong enough. This is less than 100, so it's not going to be able to lift. It's not going to be able to lift the box. Okay, I hope that helped.